Okay, in section 2.6, we're going to talk about how to combine functions, or to make the composite of functions. And so the idea here is to start off with is if you want to figure out the domain of the function, then again, that's the set of it's the largest set of real numbers for which the function has a defined real value. And what you want to watch out for the domain for these functions is that you cannot divide by 0. So you should watch out for division by 0. Another way to think about this is you set the denominator equal to 0 and solve to find the values that are not allowed. And you also do not want to take the square root or even roots of negative numbers. So both of those are no-nos. Okay, so let's just take a look at example 1. Now, f of x is, you should realize, is a polynomial because it's a sum of powers of x. This would be like x to the 0, right? So you have x to the 1, x to the 2, whatever. So you're only having integer powers of x there. And so this is a polynomial. And you should know that any polynomial has domain equal to all real numbers. So its domain is from negative infinity to infinity. There are no restrictions here. And you can say either you write negative infinity to infinity or you say all real numbers. Okay. Now, g of x is a rational function. It's a ratio of polynomials. The first polynomial is 5. The bottom polynomial is 3x plus 6. And so here, the domain is everywhere except for when 3x plus 6 equals 0. So 3x plus 6 cannot equal 0, which means that 3x cannot equal negative 6, or x should not equal negative 2. Okay? So then our domain in this case is negative infinity to negative 2, union the interval from negative 2 to positive infinity. So it's all reals except for x equals negative 2. Alright, now the last example, this is a square root, and remember we can't take the square root of a negative number. So we want x plus 2 to be greater than or equal to 0. So the domain is all x such that x plus 2 is greater than or equal to 0, or x is greater than or equal to negative 2. So in this case, the domain is, you could write it in set builder notation, it would be the set of all x in the real numbers such that x is greater than or equal to negative 2, or you could say that it's negative 2 to infinity. Okay, so that's basically all there is to it with the functions we're considering in this class. If you see a rational function, make sure that the denominator can't equal 0. If you see a square root, make sure that whatever you're sticking into the square root is a positive number.